Hi, and welcome to the session about the TableView and the DelegateChooser, which are new features in Qt 5.12. My name is Shawn Rutledge. I've been a Qt developer since about 2004, and then I joined the Qt company in Oslo in 2011. It was Nokia back then. Ever since then, I noticed that our support for touch in Qt Quick wasn't really as good as I thought that it should be, so I've been mostly concentrating on that and also on Wacom tablet support. So to make touch support better, I worked on the Qt Quick pointer handlers, which have now been renamed to input handlers. And I, along the way, fixed a lot of bugs on the XCB and macOS platforms. And I worked on a couple other things too. So the agenda for this session, we'll first talk about the Qt Quick Controls 1 TableView and the reasons why we thought we needed to rewrite it, and then the introduction to the new Qt Quick TableView, which is the replacement. We'll talk about the relationships between the models and views. Then I'm going to do a demo and walkthrough of an existing application called QPS, which I have refactored to use the new Qt Quick TableView, and then some things that are still left to be done. So here is a running example of the Qt Quick Controls 1 TableView, and it's showing the processes running on my system. As you can see, it has a lot of features already. You can sort the columns and you can rearrange columns. It has kind of a native look and feel. Since I'm running on a desktop, it looks like a desktop widget-based application. And another advantage is that the API is actually quite nice because you can use a model of some sort that exposes the named roles for each of the properties that you're going to show in each row, and then you define in QML what those rows look like. The disadvantage is, on the other hand, performance. If I try to scroll through this, you can see how laggy it is. Every time the model refreshes, it keeps jumping back up to the top. Well, the reason why the performance is so bad is because I've got quite a few columns here. This is really just a list view underneath. And every time that the list view creates a delegate for a particular row, it has to create the entire row all at once. And that means that the delegate includes a bunch of different text elements for each column. Styling depends on the platform. So there's just a lot of extra components that are being created for each row. And that's why the performance is so bad, because as you scroll through, the list view actually destroys entire delegates and creates new ones. Another disadvantage is that the data roles have to be defined in the model. So now we have the new Qt Quick TableView introduced in 5.12, and here you can see the big advantage is performance. You can actually smoothly scroll through. And the reason that works so well is that now each individual cell is a delegate instead of the entire row being a delegate. So we only have to instantiate the number of items that you can actually see in this viewport, and instead of creating and destroying them as you scroll through, it actually pools and reuses delegate instances, and then it just changes the bindings as you go through. Another advantage is that if you developed your model to work with QTableView from widgets, you can use it directly. But on the other hand, it's not a drop-in replacement for the Qt Quick Controls 1 TableView, in the sense that if you have defined roles in your model, those are not going to be used. This is also a bit like ListView, except that it's two-dimensional. It has both columns and rows instead of just rows. And the styling is entirely up to you, as with ListView. But we're thinking about adding some delegates in Controls 2 maybe in the future. So for now, you have to do more work, but you'll have complete control over how it looks, and thus you'll have more control over the performance as well. Here's a class diagram showing things that are related to this. I mean, we've got Qt Quick ListView, which inherits Flickable. And then we have TableView, which we have added now alongside, and it's very like ListView in the sense that it also inherits Flickable and therefore takes care of the flicking interaction for you. QTableView, on the other hand, is the widget that shows a table. Both of these can use the same model now, so you definitely have to have a QAbstract item model, but it could be a QAbstract table model. And then we'll get to talking about these proxy models pretty soon, about how you can use a proxy model to fine-tune the view a little bit. QModelIndex is a class which just stores the column and row that you're interested in accessing. Here's kind of an interaction diagram showing how the same model can be used for all possible table views. We have the QTableView, and then we have ListView, and here we have a Qt Quick TableView. I'll get into the details of how the same model can be reused for all of those. So the QTableView, how does it access the model? I mean, this is a widget, so it's interested in just painting delegates one at a time using QPainter calls. So let's say that we want to draw the cell here that I've highlighted in green. The QModel index will be built with column 5 and row 9 because we're in the 5th column and the 9th row here. The QTableView is going to call the data function, passing in a QModel index. Usually the role is display role, that's the default, and it expects to get back a Q variant which will have a string inside, and then it will paint the string in that cell. That's what the default delegate for QTableView does. And when you want to change the appearance, I have another session about widget programming where we'll talk about how to change the appearance of a cell in a table. Then you would specialize the delegate. So that's how QTableView works. On the other hand, the old way with Qt Quick Controls 1 TableView, it's a ListView underneath. So you can do this yourself. You can just use ListView and you can create a delegate. You've got text instance for each column. If we're painting the same cell here, this text item will access column 0 and row 9, and then it passes in a role because we're in the RSS column. So it wants to access RSS data, and it uses a string to represent this role, but that will be converted using a hash here. The model has to define a hash which maps enum values to QByteArray, which is the string that you're using to specify the role. Your data function in your model will be called with the model index in which the column is always 0, and then the enum corresponding to RSS, converted to an int, and then in your model you have to deal with that and return the appropriate data. The new table view, on the other hand, is more like the widget table view in that it will actually use the column and row in the model index, and the role goes back to being display role by default. So now your QAbstract table model will work. We'll talk about the proxy model pretty soon. But the basic idea here is that in my application I have a model which represents the processes on my system, but it defines the columns and rows, and those are in kind of an arbitrary order. And so I wanted to be able to display them in a different order. I made a subclass of QSortFilterProxy model which does that and also does the sorting and filtering that the base class provides. So this is acting as kind of a view model to tell the view how it should appear. The code that I base this presentation on is some of it is reused from a project called QPS. QPS is a really old application that was built for Linux desktops back in about 1997, and it's been maintained through the years, and nowadays it's part of the LXQt desktop, so they're maintaining it. And this is the official repo. And then I have a fork of it in my repo where I have just reused a little bit of code from that and then redeveloped the table model so that I can use it for the table view. I was hoping that I would find an intact QTable model already there, but it needed a bit more work than that as it turned out. So this is QPS from the Arch Linux repo, but this is a widget application. It's using QTableView. So I basically wanted to recreate this in Qt Quick. So let's get into the code. I started out really simple. If I show this current version, it looks like that. I've created a table model and I'm showing it in a QTableView. So here's the table view. I instantiate one of these and I tell it the model is a process model, and then I specify the delegate, and right now it's just a rectangle with text inside. And so when I show this QML, it gets put into a window with a white background, and then my delegate is a rectangle with a different color than white. So this is how you can see the boundaries between the cells. The white is showing through, and there's some column spacing and row spacing. So around each cell I have 4 pixels, and the white shows through, and therefore we don't have to have any items to draw lines between the columns and rows. So this is about as simple as it can possibly be, and the process model is a QAbstract table model. Every time you subclass QAbstract table model, you need to implement 3 methods at the very least: row count, column count, and data. So those are kind of obvious what they do. I'll show you the implementation, and then there's also a timer event because I have a timer in here to update this thing. I think it's once every 5 seconds. Yeah, start the timer with an interval of 5,000 milliseconds, and then every time the timer fires, then I update. And the update method will use this code that I brought in from QPS to refresh my model of processes on the system, and then that puts it in their code. They use a hash table to store a mapping of process ID to all of the data about the process, but I wanted to display them in the order by process ID. So I have a vector of process IDs just to keep them in order. And then in our data function, this code that I reused So improc is this data type that's provided by QPS. It has some hashes in there to store the data. So I want to pull out a particular process. This is the process information, and then that's divided into different categories. Categories are just different data types. Like, for example, the process ID itself is an integer, and then there are strings, and there are percentages for how much memory it's using and all that kind of stuff. So they have a whole series of subclasses here for different data types. This is provided by QPS. Fortunately, they had a virtual function already which can provide a string. QString can be converted to a QVariant automatically, and therefore my data function is really simple. I just always return a string. That doesn't look all that nice yet, so let's look at the next step. I have a little script here I'm using to just iterate through a Git repo and show the patches in order to do kind of a walkthrough how I develop this. The next thing I wanted to do is to change the column width, and I wanted to have column headings and scroll bars. So let's see, that looks like this now. So everything fits nicely, and we have column headers. And the column header moves around when you drag the table. So how did I do that? The table view doesn't have a header feature yet. So what I did is I just made a row with a repeater, and inside the delegate for the repeater is just an orange rectangle with a piece of text. To keep this in sync with the table as it moves around, I simply need to set the X of the row based on the content X of the table. So as you drag the table around, the content X changes, the binding changes the X of this row. So, it starts out at 0, 0, and then as I move the table, this row moves along with it. So I set the Z to 1. So I declare the row on top, and then the table view underneath, but because the Z is set, then the data will actually scroll underneath that. So this is a really primitive way to get yourself a table header for now, until we get around to providing one. In a future version of probably Controls 2, we'll have a table header. Okay, so let's look at the process model. What I had to add was this header data accessor to provide the strings to put into the header. So the section tells which column we're looking at. The orientation says it's either horizontal or vertical. If the orientation is horizontal, then I have to get this category, which is the data type for this column. QPS tells me what type that is, and then it has a name. So this is fairly simple. The column width is another feature that I added. This is not a standard way to develop a table model, but I simply wanted to expose some function to QML, so I made an invocable column width function that takes the column and the current font that I'm using in the UI, but it defaults to null. Then I use default font metrics, and those come from the QGUI application font. If you have not set the font in your QML text instances, then it's going to use the QGUI application font by default. And I can use this to calculate the widths of text even before it's being displayed. Font metrics width function. And so what I did is I used the header data first, because in some of these cases the header strings are wider than the data that we're ever going to display in there. Well, like CPU, for example. This is which core the process is running on. That's always a single digit, but the word CPU has 3 characters. So first I check the width of all of those, and then I go through all of the rows that are currently being displayed, and I actually calculate the width of all of those strings as well. Take the max of all those things, and then I store that in a column widths vector. But notice I only do this once, and then the rest of the time I just return the column widths that were previously known. And let's hope that everything will fit from then on, because I have a lot of processes running on my system already. Also, I have a max. In QML, I actually limited the width. So some of these will get elided, you see, because that's a really long command line there, and I didn't want it to take up the entire view. So I elided on the left, because the end of the command line is more interesting than the beginning. So I elide either on the left or the right, depending on which column we're in. Okay, but to actually provide the column width to the table view, you have to set this column width provider property to a JavaScript function, which takes the column index and returns a number. So I call my column width function in the model, and then I limit it to a max of 600. TableView will call this function at the beginning to decide how wide the column is going to be when it initially renders, and then it doesn't change that, because you don't really want your column widths changing automatically as you scroll through the table. So this is the mechanism that we have now, but it's up to you to define this function however you like. So what's next? I wanted to make the columns sortable, and I also wanted to reorder them, because when I run top, the user's always kind of near the left, and then the command line is to the right, and the other interesting statistics are in the middle. Now I have rearranged my columns to look very similar, and I've also made them sortable. So if we sort by CPU, then you can see which process is taking a lot of CPU right now. And in my case, it's the screen recorder that I'm using to make the video for the presentation. That makes sense. It should take some CPU. So let's look at how I did that. Okay, the main thing is that I had to start using a proxy model. It is a subclass of QSortFilter proxy model, which is something that Qt has provided for a long time. You can use it with your widget applications as well. And as the name says, it provides sorting and filtering by default. But I added one more feature in my subclass. I also rearranged the columns. So I did that by simply taking this fields enum provided by QPS. This is all the things that QPS knows how to give me. They have an enum for the field. I simply made a vector of those things, and then I said I'm going to put the columns in the same order as they are in this vector here. So in my constructor, I populate the fields in the order that top normally displays them. That's those fields, and then there's everything else that QPS gives me about the process. QSortFilter proxy model provides the sort function already. The only reason that I override or that I add this function here is to make it invocable so that I can call it from QML. And then the other functions I had to override are these map functions. The source model is the original process model that has the columns in arbitrary order. So map to source means let's take a model index representing a column and row in the view and ask what is the original column and row in the source model. I do this by direct lookup. The proxy index that's being given has a particular column. I look up in my vector which column that is in the original model, and that will now be the new column. And then I construct a new index where I use this column and the original row. And then map from source just does it the other way around. So it has to actually do a search in the vector to find the right one. And then the column width is another function that because I've rearranged the columns, the column width is now different than it was in the original model. So I again have to use the fields vector to look that up. Okay, so in the table, didn't really change all that much except that I'm using a different model now. I'm using the sort filter process model. So notice the plugin, this was there in the first version, and now I've added my sort filter process model. So I do the QML register types in my plugin. In my QML, I'm importing this org-lx Qt QPS, and then it's instantiating this model to use for the table view. The sortable column heading, so that's a rectangle now which has a wheat background, which is a lighter orange by default. We have a text for the label. We also have a text for the sorting indicator, and notice I just used a caret character. You could use an image here if you like, but I just kept it simple. And then, so I have a default state which is empty string, meaning that the column's not being sorted at all. And then I have an up state and a down state, and I used property changes to change the rotation of the caret. And it also changes the color to orange to indicate that this column's being sorted. And then when the property changes, then I emit a signal sorting. And when this signal is emitted, I go through all the columns in the model and I tell the header to stop sorting, and then calling this sort function, which has been exposed from the sort filter process model, because it has its own map from source and map to source. And I'm calling those functions in the base class here. So it will first rearrange the rows according to the sorting or the filtering that's being done, and then I rearrange the columns as a secondary step. Okay, the next thing was that I wanted to fine-tune the sorting a little bit. The numeric data was not being sorted numerically, it was being sorted alphabetically before. But now I've got it so that if I sort by the PID column, which is the default, then those are in numeric order, whereas other things are being done in alphabetic order. I added a filter feature, and I also added the control over the initial sort, because when you click on CPU, you usually want to see the top CPU using process first, but when you click on something that needs to be medically sorted, you usually want to sort A to Z, right? So the way that is done, there's a special role for defining the initial sort order. So I use the initial sort order role from the data function to set the initial state when I call this next state function. And then there's filtering. So now I've added a text field in my toolbar, which is at the top of the window. Every time that text is edited, it's going to reassign this filter text property in the sort filter process model. So set filter text will be called, and then we're going to call set filter regular expression on the inherited sort filter proxy model. So now we've got this feature again that I can find all the QML processes running on my system or something like that. The next thing I wanted to do is introduce DelegateChooser, which is another new type in Qt 5.12. So if we run this, I've now got a different delegate type that I'm showing for CPU and memory usage. It actually shows a bar graph. So how did I do that? So my table view now has a more complex delegate. Instead of simply the rectangle with text on it, we've still got that one here. I have support for different data types. So if the data type is a percentage, then I'm going to show this bar graph delegate. If it's a string, then I'm going to elide on the right. And otherwise, we have the same delegate that we did before. So in order to provide these data types, I had to add that to my process model as well. So now, in addition to the roles that Qt already knows about, I've added some more user-based roles, user roles. So sorting was one of them that we added earlier, and then the type is this new role that I'm introducing here. It'd be kind of nice if the category would just tell me what type it is, but I didn't get around to making a virtual in there for that, and that's not in the QPS code. So I just said, let's just look at all the fields that we know about. If it's a CPU or a memory, then that's a percentage. These types are sizes and so forth. And then some of those I switch on in the QML to decide what delegate I'm going to display. We've got this DelegateChooser. That's the other new type in Qt 5.12, and it is a component which decides which of the components that are declared inside will actually be used. The bar graph implementation is just a rectangle that draws another rectangle on top for this green bar, and then it has text on top of that. And notice that I had to get the data numerically, and I happen to know that if it's sortable, it's also a number, and so I just converted to a double here and returned that as my variant. So now this delegate is able to use that to define the width of the rectangle. So yeah, you can have as many roles as you like in your model, and this was what you always had to do before when you were using data roles to display in a list view. You had to have a lot of user roles, but here I just have a few of them because the columns are actually significant now. So you can very easily mix these techniques. And if we take this a little bit further, you'll actually be able to use this for the list view as well. So if we take the next step here, that's what I did. I put in a lot of roles. I begin with all of the data field roles. I called this insert field roles method, and I just went through all the enums that QPS knows about. So I actually just insert into this hash all of the user roles. So you override this function and you return your own hash. So I insert the ones that Qt already knows about, and then I insert a few more of my own, and then I call this insert field roles to insert all of the enums from that QPS knows about. And actually it's possible to just do this in a loop, because there's a trick with QMetaEnum. As long as your enum has been registered with the QEnum macro, that could work. So the result is I can actually just do this with a list view now. That's what that looks like. And then if we look at the code, here's a list view, and the row for the delegate just has a bunch of text items. And notice that here I'm just using those roles that I defined in my hash. I can just use them directly to say they'll be set as context properties on the list view, and so I can just use those directly to access the context property to get the text. So that's the list view, and then if you're using the Qt Quick Controls 1 table view, it does a very similar thing. And you define the table view columns in there, where you specify which role you want to access, what the title will be for the header, and what the width will be. And again, I get to reuse this column width function provided by the model, and then I add a little bit of extra space so it's not too jammed up. So define all those columns. That's kind of verbose. It took a lot of lines of code to do it. So that API is kind of nice, but since we're not doing this with the new table view, we're thinking of When you use a proxy model as your model for a table view, then that proxy model acts as a view model. You may have heard this term in other contexts. So we think that in some future version we should provide something like that. So now I have a process model which is able to work with all possible views. I can use a QTableView, or I can use the new TableView, or I can use the old TableView, or I can use a ListView to display the same data, because the data roles are being provided in the model. If the role that's being asked for is one of the data roles, then I will use that instead of the column. But otherwise, display role is kept as it was before. I simply return the string provided by QPS. So this is how you can make your models universal to work with QtQuick and with widgets as well. Use this shebang mechanism to launch QML. So now I can actually just go to the command line and I could actually run the QML as an application. The next thing I wanted to do is to make the column headers resizable. Like that. So this is a feature that's not provided by anything that we're shipping yet, but I wanted to show you how to do it. So how did I do that? My sortable column heading is still the same rectangle that it was before, except now I've added this splitter item to the right. It's invisible because it's just an item, it has no color, but its width is 12, so that defines the space within which I can put my mouse cursor and start dragging this item around, because it has a drag handler inside. When you declare a drag handler in an item, then by default that item becomes draggable. It will simply move the item. But the y-axis is disabled so that I can only drag horizontally. As soon as I release the mouse, active change goes to false, and then we're going to call this force layout function, which is an invocable that the table view has. When force layout is called, it's going to end up calling the column width provider function again to set the widths of those delegates. The drag handler simply allows you to drag the splitter item. Then I use the binding to define the width of the delegate. So the initial width sets the initial position of the splitter. The width of the header for this column is in turn set to the splitter's x position plus 6. Then when I drag the splitter, it actually resizes the width of the column header at the same time, and then as soon as we stop dragging, then it lays out the table. So the trouble is that there's this lag that first you resize the header, and then when you release, then the table will catch up. And the next thing I wanted to do is to add this feature that we have from widgets and also from the Controls 1 table view, that you can drag columns around. So I did a similar kind of thing where we don't relay out the table until you're done dragging the column. Like I said, every time you add a drag handler to something, you're making it possible to drag that item. But now we've put another drag handler on the column header itself, and when the mouse is released, the drag handler is no longer active. Then we're going to emit a signal in which we provide the x-coordinate at which we have released in scene coordinates, meaning relative to the top left of the entire view. I added a new function, Reorder Column, in which I specify which column is being reordered and where we want to reorder it to. And then at the end, after that, I call force layout again on the table view. So of course, our sort filter process model is the one that knows about rearranging columns, so that has to be implemented there. So the reorder column takes a column and an X. Let's take the PID, that's the 0 column. And I drag it over here. There's 0, there's 1, there's 2, there's 3, there's 4. So if I drop it right here, I put my mouse cursor right there at that gap, what I'm saying is I want to insert this column 0 before column 4. So that's what it says, reordering column 0 before column 4 at 300. 300 is the position of column 4. So I had to actually iterate all of the columns in order to find that. And then, as the documentation tells you, you should call begin move columns before you do any reordering, and then you can do the reordering, and then you can call end move columns, and that will emit the signal, which TableView then uses to know that it should re-render itself. But TableView isn't that smart yet, so that's why I have to actually just call force layout myself in order to make this actually work. So this is something that, again, should be built into a future version, if we're going to provide column headers, drag and drop should be one of its features. It's a prototype of what we'll be having later. And I think that was it. I don't have anything else to show you. So let's summarize the things we've run into that we still need to work on in the future. Obviously, we need to have a header view because it shouldn't be this much trouble to implement your own. And then a feature of the header view would be resizing columns and a drag and drop of the columns. It'd be nice to be able to select ranges of cells in the table. I haven't shown you an implementation of that yet because we're still working on it. But again, it's probably going to involve drag handler to drag out a rectangle across the range of cells that you want to select, and then it will have to calculate which cells are those, and then there'll have to be a selection state, which will be a new role or something like that, so that the delegate can be rendered in a different color. And of course, so far you're completely in control of the appearance of your delegates in the table, but we would like to provide some reusable delegates that you can just instantiate. The table model so far I've implemented in C++, but it'd be nice if there was a QML table model just as there is a QML list model. And I have a colleague, Mitch, who's working on that. We expect to ship that in a future version of Qt. The proxy model. There have been offers from outside contributors to contribute their proxy models, and we have some ideas of our own about how to implement them, so we need to somehow merge this all together and come up with a proxy model that we can actually ship with the future version so that you don't have to create that in C++ either. So thanks for watching. See you next time.